Okay, being able to do squares and cubes on slide rules is great. But let's say I want to take a base and raise it to some power, something like power of 2.25. How would I go about doing that? Well, on a slide rule, the logic that I'm going to follow is this. All right, let's say I want to raise the number x to the power a. Well, if I take the natural log of x first, would that be equal to n, and then multiply this number n by a, and set that equal to b, and go ahead and exponentiate both sides, I get on this side e to the b, and that's actually equal to x to the a. Well, in order to see this, what you do is you replace n times a with natural log of x times a, right? Since natural log of x is equal to n, we just make a little substitution in there. So a times the natural log of x. We had that rule before that a multiplier out front is the same as an exponent inside. So a times the natural log of x is equal to natural log of x to the a. And we know that a times the natural log of x is equal to b, right? Since n times a is equal to b. So okay, here's the important part right here. And if we go ahead and exponentiate both sides of this, we exponentiate this, cancels out the natural logarithm, and we get x to the a, and here when we exponentiate this, we get e to the b. So let's go ahead and take a look at our slide rule, see how we're going to use this. Let's say I wanted to raise 2 to some power. Well, I'll go ahead and grab my 2 right up here on the double log scale. Right? And as I said before, right, if we take the natural log of that number, set it equal to some n, and then multiply that n by the power that we're looking to raise that number to. Right? Here's the natural log of 2. The process for exponentiation to any base and any power. You get your base up here, line up the index, go get your power, let's say it's 4, and then go back to the log scale. So 2 to the 4 is actually equal to 16. Here's 10, that's 12, 14, 16, 18, 20. 16 right there, right? If I do 5, that lines up with 32. 6 would line up with, here's 60, and that's 64 right there. These numbers start increasing very, very rapidly here. Alright, but this will work if I want to take something like 1.4. Well, I'll go get my 1.4 over here. I think that would be 1.4 right there. Right here's 1.2. Here's halfway in between. 6, 7, 8, 9, 10. Also, it's directly underneath the decimal. That's 1.4 right there. Alright, I go ahead and line up my index. And let's say I want the 5th power. Alright, that will get interesting here. Let's say the 4.5 power. 1.4 raised to 4.5. That should come out to, interestingly enough, 4.5. 4.5. And indeed it does. I just checked it on my calculator. So that's how you can use the double log scales in order to calculate exponents.